As we saw, the multiplication principle applies when you want to count ordered structures, because you have to recover the partial outcomes uniquely from the final outcome. And this cannot be applied, for instance, as we saw in an example, when you want to obtain a set, for instance, of 2 people among 3, because you cannot recover from the final outcome, that is the set, who was chosen in the first step and who was chosen in the second step. There is another principle that helps us in such a situation, the division principle. Well, it is very simple. It simply states that if you need 5 grams of coffee to fulfill 1 mocha pot, then you need 250 grams of coffee to fulfill 50 mocha pots. Let us have a precise statement of the division principle. Well, assume you have 2 finite sets, x and y, and assume that each element of y, which is a smaller set, corresponds to m elements of x through a function from x to y. So there are exactly m elements of x that are sent to each element of y. So correspondingly to 1 element of y, we have m elements of x. So the number of elements of x is m times the number of elements of y, which is often used in order to obtain the number of elements of y, which is therefore the number of elements of x divided by m. As an example, we want to count the number of committees, that is, subsets of 3 people chosen from a group of 27. Well, we know that the multiplication principle cannot be applied, because if you form a set in 3 steps, we choose the first, the second, and the third element of the group, we cannot recover the partial outcomes from the final outcome. So we first put them in a sequence, and we consider the set X of the 3 sequences that we can form with the 27 persons with no repetitions. So we form distinct sequences. We choose the first, the second, and the third element of the group. We can apply the multiplication principle, and we have 27 times 26 times 25 possible elements of X. Now, we consider the set of committees of 3 elements among 27, which is the sets of 3 elements among 27. Now, let us consider an element, ABC, of Y, a committee, ABC. How many ordered sequences can we build from ABC? Well, there is the sequence ABC, others. How many? Well, factorial of 3 permutations of ABC, CAB, BCA, and so on. So we have a 6-to-1 correspondence from the set X to the set Y. And therefore, we can apply the division principle, and we obtain that X exists times the number of elements of Y, or Y, which is the sets that we want to count, has got the number of elements of X divided by 6. So 27 times 26 times 25 divided by 6.